this year. And talking of that, why is it suddenly everywhere? Well, it's become popular in the last year or so because it facilitates simple yet rapid development on embedded devices. It has all the powerful features of Python that you would expect. Sometimes, depending on your device, it might have more or less of the standard library that comes with Python. Importantly, it has a transferable skill set. So I work in Python during the day, building large, scalable websites, but I can use the skills that I know as a Python developer on microcontrollers and embedded devices, which makes it rather a fun thing to do. And also, this being Python and MicroPython, it has an outstanding community. So that's it, really. As I mentioned, MicroPython, it's all over EMF, because all the badges that you're going to get run a build of MicroPython. MicroPython's actually all over the UK as well. Now, I can't see an awful lot because I've got lights in my eyes, but could you put your hands up if you've heard of the BBC microbit device? Okay, that's pretty much everybody, which is what I was expecting from EMF. So you would be unsurprised then if I told you that 1 million of these devices have been delivered to the UK's Year 7s, so that's the year when you're turning from 11 to 12. And this was a partnership created by the BBC. One of the partners was the Python Software Foundation. I'm a PSF fellow, and so I was the person who helped organize for the PSF the collaboration with the BBC. And all the work that I'm going to show you on the microbit today for MicroPython has been done by volunteers here in the UK and around the world. Okay, so nobody's paid people to do this. So you could also use software from one of our other partners, so Microsoft. If you go to their tent, they have an alternative programming environment that you could use on the microbit as well. MicroPython is all over the world. So Damien George, the creator of MicroPython, is Australian, and he ran a successful Kickstarter, which I'll talk about later on. But the PyBoard, he tells me that he gets fan mail from children in Saudi Arabia who are using the PyBoard and MicroPython in their lessons. In the US, it's kind of all over the place. And this is the thing that I really like, because I'm a bit of a space nut, is that MicroPython is going into space. I'll talk a little bit about that as well soon, but I think that's really cool, is that I could be writing in a language that I could use to program satellites in a few years' time if this project comes to fruition. So this dapper-looking chap is Damien George. He's a physicist who was, until 2 weeks ago, based in Cambridge here in the UK, for a bit of fun, he created MicroPython. Why wouldn't you want to re-implement Python 3 in your spare time? But that's what he did, and it's become this hugely successful project. So, how does MicroPython work? So, I'm not going to give a very technical explanation of this, because you can find out the technical details online. But this diagram essentially shows you the flow of what MicroPython is doing. If you start at the red boxes on the left-hand side, I'm not sure if you can see it that well, but it says REPL prompt, user scripts, and compiled strings and things. That essentially represents Python code as we would see it in our editor. That goes through several steps to get to the compiler. So the lexer will tokenize the Python script. The tokens are then sent through the parser. So you get the parse tree, which is what the compiler uses to turn into something that can be executed on the device. Now, for the microbit, we have a virtual machine. So it's compiled to bytecode. The bytecode is loaded into the virtual machine, and it is executed on the device. I believe that's the same for the EMF badge. So the virtual machine executes the bytecode, and stuff happens. You have native code as well, so MicroPython can compile to whatever executable you might need for the particular device that you are programming. And there's also something called Viper code, which I have absolutely no idea what it is, because I've never been involved in that part of the MicroPython project. But it sounds cool, called Viper. Anyway, that's how I know a little bit about what it is, but ask me later. That's essentially how MicroPython works. It's a very, very simple system. And the important thing that you need to know is if you're thinking, right, okay, well, Nicholas hasn't really told me that much about it, I know what I'll do. I'll go to the micropython.org website, find where their GitHub repository, and see what I can find out about this code. Some things that you need to know. Because MicroPython is designed to work in highly constrained computing environments, it does not follow traditional software engineering practices that I might use when I'm writing great big websites, for example, in Python. So basically, Damien optimizes first. He uses lots of creative solutions and tricks. If he can, everything's about size, so everything has to be as small as it can. So clarity, which is something that developers, especially Python people, like to trump as a benefit of the language. In the C code, the implementation of MicroPython, we're looking for smaller code. More smaller code. Goto is not discouraged in the C code. Programmers will understand that's rather a contentious issue, but in the case of MicroPython, it gives us some efficiency here. Because we don't have a lot of RAM, everything's optimized for not a lot of RAM, minimize the stack usage. And all the decisions that Damien makes about these optimizations that I've flung through with wavy, hand-wavy type of description are based on analysis. So he's looking for how he's using analysis to work out where he can make the best optimizations given the particular platform for which MicroPython is being built for. So here's Damien again, and he's always asked the same sorts of question, which is, why do you do it this way rather than that way? Why do you do it this way rather than that way? Why are you doing goto rather than blah, 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 blah? Why blah, 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 blah? And essentially, it all boils down to one essential factor that Damien is concerned about, and that is to minimize RAM usage, because we are working in a constrained environment. If you are interested, and I encourage you to have a look, because it's a very friendly community, go along to micropython.org. MicroPython supports lots of different devices, not just the microbit or the PyBoard or the EMF badge. There's lots of people doing crazy stuff with lots of interesting embedded devices. Micropython.org is the place to go. So why would you want to re-implement Python 3 for microcontrollers? So I asked Damien this a couple of days ago when I was exchanging emails with him. And he said, well, you know, because it was there, really. It was a fun thing to do, and he wanted to see whether he could do it. And so he's done it. Congratulations to Damien. And also, Damien loves writing in Python, and he wanted to make it easy for people to program using Python in such constrained environments. So this goes back to my point about having a skill set that's easily transferable. So how did MicroPython come into being? Well, Damien sat down and he figured out, well, could this work? After a spike of code, yes, it could. He put his proposal on Kickstarter, and almost 2,000 backers pledged almost £100,000 for him to complete the work. And they got a little PyBoard, which I don't have on me right now, a very small device which they could then use to play around with MicroPython. About 9 months ago, Damien ran a second Kickstarter for conversion of MicroPython to run on the ESP8266, which is a system on a chip that has built-in Wi-Fi. And it works, which is wonderful. And he had almost 1,400 backers who pledged almost £30,000 for this to happen. So Damien is working full-time on MicroPython on this. And of course, there's the BBC microbit. So this is how I know Damien, because my involvement in MicroPython has been through the microbit. One day we were sat in London having a cup of coffee, wondering how we would describe to the BBC what our vision of MicroPython on the microbit would be. And we literally sketched it out on the back of the table mat and took an arty-farty photo of it, really. And that's what we showed them when we went into the meeting. But the important thing is that 1 million children and an international team of volunteers have been involved in the microbit. The 1 million children obviously get these devices and they can learn to program with them. And the international team of volunteers, many Pythonistas, many people who for the first time have started to work in an embedded environment like myself. It's been an interesting sort of an adventure. And they've been doing some crazy stuff. So this is a robot built by a friend of mine called Radomir, who is a Polish chap based in Switzerland. And he essentially, well, by the looks of it, got some motors and nailed them together with a microbit. And this is what the result was. Kind of cute in an all humans must die sort of a way, really, isn't it? I think he does it again. Yeah, here we go. Very, very silly. The important thing is about the microbit is that we want to inspire creativity. With silly robots like this, we hope that things that kids could make in their CDT class, remember, this is just some motors nailed together, well, glued perhaps, together with a microbit and some very, very simple Python. I think it's only about 15 or 16 lines of Python code that gets you to here. Okay? So, this is the bit that I've been working towards, which is the live demo. So, I believe tomorrow you get your badges. So here's a sneak peek. Yes, it works. Here we go. So, aha. So here's the badge. It's running MicroPython. And what I'm going to do is give you a very simple outline of what you need to do to get in touch with Python on this device so you can start hacking with it. You first of all plug it in, which is easier said than done when you're live on stage at EMF Camp. There we go. And if I go to my REPL here, I should be able to... Oh, that's interesting. I obviously didn't sacrifice enough chickens to the demo gob this morning. Let's see what I can see. Okay, so we have the board. I can do it this way. So when you plug in your badge, it will be mounted as a flash storage device, and there's nothing on there. Oh, man. There we go. And what the device will do is it will attempt to look for a file called main.py in the root directory here of the file system, and it will attempt to run whatever Python it finds in there. Now, the badge team here have told me, and another caveat here is that I only got this badge about 2 hours ago and have spent about 15 minutes playing with it, so there's live demos for you. What it does, it actually runs a boot.py file, if it also finds it, and the main file that it runs is going to be in home main.py, which is this beautiful piece of Python code. But what I can do, and this is without the aid of a safety net, is if I rename this to main.py2, and I rename this to main.py,